This is the first in a series of video-based lessons that will build on the introductory videos and introduce relational data model as the foundation of modern database systems. We begin by discussing the basic RDM concepts, some of them already introduced in the introductory videos, but going into more depth. Specifically, the create table SQL statement will be examined in detail, and we will begin to build our sporting goods database. We will also introduce a few additional projects which will allow us to get more practice and also deepen our understanding of RDM concepts. This material is covered in the first part of Chapter 3 in the textbook. You are already familiar with tables representing entities such as customers, with rows representing an instance of customer entity and columns capturing different customer attributes or characteristics. You're also familiar with relationships or connections between tables from the introductory videos. Both tables and relationships between them provide the basic building blocks of the relational data model, RDM. The structured query language, SQL or SQL, is the language of RDM and is used to do just about everything, from creating tables, establishing relationships, to retrieving information, aka querying the database. The SQL uses keywords such as select, where, and, etc., together with tables, attributes, and relationships to formulate queries such as the one from the sporting goods database verbally described at the bottom of this slide. The tables in a relational model, similar to data sets you typically encounter when working with spreadsheets, consist of a heading with a table and column names, followed by rows of data values. The customer table in our sporting goods example may include last name, first name, age, gender, phone number, and a host of other columns describing different attributes of customers. The body of the table consists of the actual customer data values, one row per customer. Each of the data values in the body of a table is of a specific type. The data type defines the set of allowable values and operations on these values for each of the columns. Most of the data types can be divided into two broad groups. One, numbers, and two, text. There are quite a few different number formats, but those also roughly divide into one, whole numbers or integers, and two, fractional numbers, decimals, floats, double precision, etc. There are subtle differences between data types in different DBMSs like SQL Server, Access, MySQL, and Oracle. In MySQL and also Oracle and SQL Server, text of fixed length is represented with char for ASCII character data or nchar for Unicode character data, and text of variable length with varchar or nvarchar data types. If you know that a sporting goods customer's zip code has exactly 5 digits, which are interpreted as characters, you would use char of 5 for fixed length data type. For customer names, addresses, and other text of variable length, varchar data type with a maximum character limit would be the way to go. Even dates, as you may recall from working with spreadsheets, are whole numbers, with times represented as fractions. As was already mentioned, there are several data types representing fractional numbers. Some are optimized for use in financial and scientific calculations where precision, number of significant digits after the decimal, is important. For us, we will use decimal with MySQL and double with Access. Sometimes fractional data types are used even though we know the value is a whole number, such as quantity ordered in the sporting goods example. One of the reasons for this is that quantities are going to be involved in calculations, so it may be better to keep them having the same data type as prices and other parameters. We now move for a moment to a more practical aspect of working with tables in a relational database. This step assumes both MySQL Server and Workbench Client are installed and running. to create your first MySQL table by typing your first SQL script, please use Notepad++, also assumed to be installed. We're going to start by opening Workbench and creating a new sports schema, which is a technical reference for a database, and we'll make sure that it's active by double clicking on it. So I already created sports underscore videos database that I'm going to use for these video recordings and made it active, but you would right click in the navigation window to create schema, give it a name. I'm going to say something like sports underscore test because I have a number of sporting goods databases, and then click apply button twice, and then that the second apply is going to run the script and create the database. Then close this window and then double click on the database to make it active. Since I don't need sports test, I'm going to drop it and then make sports videos active. Next, navigate to the class folder and 02 Relate DM subfolder, and then lectures and sports subfolders, 1, 2 more levels down. So there you will find, among other files, a script called MySQL 201 create customer table, which will open with Notepad++, and then make sure that have sufficiently large font for you to see. Then what you want to do is use the current slide to complete the script, making sure you save all the changes. So the next thing I'm going to do is I'm going to look at the script on the side and complete it. The first thing I'm going to do is show you how to use comments, which are enclosed in a set of open close forward slashes with an asterisk in adjacent to them or next to them, and I'm going to give it a name MySQL2 underscore 01 underscore create cust tbl.sql, essentially just repeating the name of the script. Then I'm going to create table called customer. I'm going to open the parentheses, which will automatically close, but I'm going to delete the closing parentheses to make sure that it matches with the one at the bottom. So in addition to these data types already shown, I need to insert a customer ID, which is an integer. Make sure you separate the columns with commas. Then last name is a var char of size 50, which is sufficiently large for what we need. Then we're going to have a first name, also var char of size of 50. Age, which is an integer, just like customer ID. And finally, gender, which is coded as M for male and F for female, so it's a char of 1. Make sure you have a comma after that one as well. Sometimes I try to indent these columns, or the indentations and tabs and things like that are generally not working all that well, so I'm just going to leave it as it is and make sure that I save all the changes. So the next thing to do is to either open or copy paste the script into Workbench and then run it to see if it successfully creates our first sort of instance of a customer table, because we'll have to change it later on as well. I'm going to generally do the copy paste part, most of the time ignoring the comments, and I'm going to do that in the SQL editor, which I believe also has a sufficiently large font size. And unless there are any mistakes, I'm going to run it with this Thunderbolt looking execute script button. Generally, after you run the script, you ought to get a confirmation that the database or table in this case was successfully created, like right here at the bottom, or you're going to get some kind of error. The first step with when you encounter errors is to try to fix them yourself. And if that, doesn't work, then email me or post the question to the class forum. Generally or typically, there is a missing comma somewhere or a parenthesis that is not closed, although the error description here in the output might not really indicate that all that well. So because the table has been created, it should appear under the tables, and sometimes this needs to be refreshed for this to work. And then if you can right click on the customer table to select rows, you will see that there aren't any because we just created a structure for the table. But you should be able to right click and use a table inspector to see the columns and all the data types that were associated with each one of them. So at this point, I'm going to switch back to the presentation and I'm going to pause.